Good evening, everyone. Can you all see me? And am I audible to you? Please type in the chat box. Please type in the chat box. Am I audible to you? And can you see the screen clearly? No responses. Yes. Okay. So I came a bit early today just for sharing few things with you. So are you all getting these notes? I mean, did you all get the notes of yesterday's class? We have already uploaded this in the Telegram channel. So did you see it? Hi, Srinivas. So did you all get the notes of yesterday's class? Yes. Okay, so till the completion of this course, after the completion of every lecture, we will be uploading the notes in the Telegram channel. So whoever is here, so please subscribe to our Telegram channel. And also, the content is of much use at this point of time for all the GATE aspirants. I request you to like the video, and you can share and subscribe the channel as well for further notifications. Okay, and you can attend. You will be get notified of all the free courses that we will provide for you if you subscribe the channel. Okay, so that's what I want to talk to you today before starting our course. So I hope it's 10 o'clock. So can we start? And let's end soon. Okay. Yeah, IIT JAM, you can use this course, but not completely, I guess. Okay, because in JAM, syllabus is a bit advanced. JAM is not some Kisan JAM or some other JAM. Okay, it's joint admission test for MSc. So can we start? We'll end a bit early today. Clear? So if you see in yesterday's class, we have talked about limits and we have seen what is a limit and different cases of obtaining the results of limits, correct? So today we'll start with the concept of continuity and differentiability, and we'll hopefully finish this in this. So coming to the revision class, so before straight away going to the topic of continuity, I just wanted to give you one result in limits that yesterday I didn't give because of some time issues and all. So one good result of limit is if limit extends to a f of x does not exist and limit extends to a g of x does not exist, still, or you can say it, one can exist, hopefully this can exist, you can write, for example, still there can be a chance that limit extends to a f of x into g of x exist. There's a chance that this can exist. Okay, for example, if you take a tends to 0, example, I'm giving you one example to know this. Limit x tends to 0, 1 by x. What's the value for this? This limit does not exist. We have seen yesterday, correct? So limit x tends to 0, 1 by x does not exist, and let us take this limit as limit x tends to 0, for example, x squared. This value is 0, so this is existing. So this limit doesn't exist, but this limit gets existed. So, and we know limit x tends to 0, this f of x into g of x, which is 1 by x into x squared, 1 by x into x squared is equal to limit x tends to 0, x, and this value is 0. So there can be few instances where one of the limits may not exist independently, but I mean, in particular, but the product of these functions can have a limit at a particular x value. Clear? This is a result I thought of giving you yesterday. Of course, it was not asked after 2011, but it's a good point of limits, so I thought of giving you this. Clear? So can I go ahead for today's topic? All of you, please respond. Can I go ahead for today's topic? Yes. So see here. Now what is continuity of a function at a point? Let us see. Continuity of a function at a point. So what is continuous? Basically, if it doesn't have any discontinuity in between, we say something is continuous. Correct? For example, if you take a bridge, if there is no breakage in between, we say the bridge is continuous. Similarly, some thread or something like that. So if you see these points, then mathematically we define a function as, the continuity of a function at a point as a function f of x is said to be continuous at at the point x is equal to a, at the point x is equal to a, if limit x tends to a, f of x, you know how to evaluate these limits. So whatever is f of x here and whatever might be this value of a, yesterday we have seen a lot of techniques for evaluating limits for different variables and different functions. So if you see limit x tends to a, f of x, this should be equal to f of a. And this condition you generally see in many of the books. So now let us see what is this condition and how, why this should be mandatory. So let us try to draw one graph. Let me change the color. Okay. 0 x f of x. Okay, let us suppose there is one function in this format, something like this, and this is the value of x where x is a, and this function is clearly discontinuous at this point, capital A. Correct? Can you all see this? Because if I zoom this part, you can see there is some breakage at this point. Correct? So you can all experience this function is not continuous for the time being. Okay, so let me put it back. Okay, so now let us write this a somewhere else, maybe here. Okay, so see now why this condition has to be satisfied. Look, let us suppose this value on y-axis is L. Okay, and f of x is not defined at this point, but let us suppose f of a is defined at some other point like this. This value is f of a and this point is a comma f of a. Okay, means basically you see split function sometimes f of x is equal to, for example, 1 by x for x not equal to 0, and for x is equal to 0 they will be giving some other value like 2 or 3, something like this. Correct? You have seen split functions means at a particular point where the function cannot be defined, they will define some other value. This is one such case where the function doesn't possess any value along its normal path, but here it has a value. Now, why this condition has to be valid? Let us see. If this limit has to exist, see in yesterday's class I already told you, if this is x initially and this is your f of x, then as x tends to a means if this x is moving towards a, this f of x will move towards L. This is what we have seen in yesterday's class. Similarly for the right-handed side. See, as x tends to a, this f of x tends to L. Now tell me one thing. Please, now this is the important point where you will be learning why this condition has to be satisfied. So please listen here. Suppose, let us assume this point which is here initially, if this point gets settled here, something like this, will this function become continuous? Please say yes or no. Suppose if this point which is here if it gets connected between these two edges and if it makes a continuous path, can I say this function is getting continuous? Yes or no? Please, all of you, respond. Yes. So geometrically, I want all your responses because I can't see your faces. So please respond. Okay. So now geometrically, if this point is coming here, what does that mathematically implies? If this point is settling here, which means this f of a which is here is settling here, which means this f of a should be equal to L for continuity. This is what you know. For continuity. Okay. So are you all okay with this point? If you are okay with this point, then we can proceed. Yes? Okay. And what is L basically? We have denoted this limit extends to a f of x as L. So which means for function to be continuous, we should have the limit value at that point should be equal to the functional value. Okay. So if this is the condition that gets valid, then you can say this function f of x is continuous at this point, x is equal to a. Clear so far? Did you all understand the concept of continuity at a particular point? Please respond. Did you all understand this? So, okay. So if you understand this, we'll move for continuity of a function in an interval. Continuity of a function in an interval. And today we'll see some good points about differentiability and what is the physical meaning of differentiation and all. Okay. So please maintain your consistency in attendance to the sessions. So continuity of an interval in a function means for f of x to be continuous, in x belongs to a comma b, means in this interval if I want to say at every point this function is continuous, then Okay, since we didn't write if, we don't write then see here, for f of x to be continuous in x belongs to a comma b, it should satisfy 3 points, and first point is f of x is continuous for all x belongs to a comma b, means at every point in this interval this function should be continuous. Means, for example, if you see, if I am telling you that if this is xy and if this is some function y is equal to f of x, and if I am telling you that this function is continuous at the points between the points x is equal to a and x is equal to b, then you know the function has to be continuous at every point in between this x is equal to a and x is equal to b, which means there can't be any breakage to the function. Okay, so make this one point. Second point, limit x tends to a plus f of x. Can you tell me what does this equal to? If this limit, if this function has to be continuous at this point, can you tell me what should be this right hand limit value at f of x, and at x is equal to a for f of x? So please tell me what should be the value of this limit if this function has to be continuous at this point x is equal to a. It should be f of a. It's common, correct? Because you know, for the continuity of limit, for the continuity of function at a point, this limit has to be equal to the functional value, correct? It's f of a. Similarly, if I write limit x tends to b minus f of x, what should be this equal to? What should the left hand limit of this function at this particular point x is equal to b, what should be this equal to? It should be equal to f of b, correct? So this should be equal to f of b, which means you will tell that this point is getting connected with its neighborhood point so that there is no initial breakage here. Similarly, there is no final breakage here if left hand limit is equal to functional value, and you also define this function is continuous at all points. So totally this function is continuous along this a comma b interval. Clear? Did you all understand how does these three conditions come for a function to be continuous in between this interval a comma b? Is that clear to all of you? Asymptote is something like where the functional value touches the extreme x-axis, basically, or it can be the y-axis also. Basically, it's if I say this graph y is equal to 1 by x, it don't touch, sorry. Then we say these two lines are asymptotes for this, means they denote the extreme values of these functions somehow. Okay, then these two lines are called asymptotes of this curve. Clear? Someone asked, it went on. So see here. Anyhow, now let us talk the concept of differentiation. If you understand the concept of continuity, let us talk the concept of differentiation. Look, we'll talk about slope and all, see how it goes on. Before straight away going to the differentiation, I just wanted to ask you one question. For the limit to exist at a particular point, should the function be continuous? Please tell me. For the limit to exist, should the function be continuous mandatorily at a particular point? No, correct? Because if you see, when we are discussing the concept of limit, I never talked about functional value relating to this L, correct? I told you this L is something which is independent of this function, correct? I told you this, and this is y is equal to f of x, and of course this is also y is equal to f of x, and I told you this L and this f of x doesn't have any connection. So which means even at this point, if the function value is not defined, still your f of x, when it tends to a, this f of x will tend to L, and as per the definition of limit, still we write limit x tends to a, f of x is equal to L, correct? This is what we write in case of limit. We never linked this L with this functional value here, correct? So for the limit to exist, function need not be continuous, but for the function to be continuous, should the limit exist? Definitely. For the function to be continuous, should the limit exist? Definitely. Yes, because while defining the condition for continuity, you told this limit, okay, at a point we are talking, so limit x tends to a, f of x should be equal to f of a. Means if you want to validate this condition, definitely this limit should exist mandatorily, correct? So for the function to be continuous, this limit has to be existing definitely. But for the limit to exist, function need not be continuous, because we never linked the limit value with the functional value while discussing limits, correct? Is that clear so far to all of you? Let us write those two statements. For the limit of a function, to exist at a point, the function need not be continuous at that point. The function need not be continuous at that point. Okay, clear to all of you? I hope it's clear. Yeah, good. So now we'll step on to the concept of differentiability. You should know the concept of continuity in order to move on to differentiability. So let us see what is a derivative and all. Derivative or differentiability, you can write maybe differentiability of a function. Differentiability of a function. Differentiability of a function. Okay, so now how will you define a function is differentiable at a particular point or not? See, for examining continuity, you have given a mathematical condition that for the function to be continuous at a point, this limit should be equal to functional value at the corresponding x value. Now, if you want to define what is differentiability, how will you define the mathematical condition for that? So please tell me if you have any idea. Please, any one of you. Slope. Okay, so let us see what is slope and all. Okay, so a function f of x is said to be differentiable at x is equal to a if limit x tends to a, f of x minus f of a divided by x minus a exists. This is the mathematical condition. Okay, so now let us see, of course, left hand limit, and see, basically this is the differentiation formula, and this is given as f dash of x. Okay, let us write that in the next part. If and f dash of x is equal to, at x is equal to a, of course we need to talk at a point, derivative of f with respect to x at a point x is equal to a. This is equal to limit x tends to a, f of x minus f of a divided by x minus a. Okay, and this is how you say if this limit exists, you say this function f of x is differentiable at this point x is equal to a. Now let us see why this is the particular formula, f of x minus f of a divided by x minus a. Let us see why this is the only formula. So see here, let us try to draw one graph x, y. So if you are talking something called derivative, what's the physical meaning of derivative? Rate of change, correct? If you are writing dy by dx, means what does this mean to us? For a given change in x, for a given difference in x, what is the difference in y? This is what dy by dx tells you, correct? Means for a given change, if y is equal to some function of x, then your dy by dx at a point tells you that for a given change of x at that particular point, what is the change of y? So let us see that with the help of a graph. So let us suppose this is one function, some random function, y is equal to f of x. Okay, so now let us suppose this is point A, then this function is continuous. So can you tell me what could be this value? Can you tell me what could be this value if this is x is equal to a? Okay, let us suppose this is a. Can you tell me what could be this value here? This is, I want responses from all of you. If that is x, then what is this point? It is f of a. Next, if this is x, what is this point? This is f of x generally, correct? If this is x at some random location, then this is f of x. Now, if I want to write dy by dx, means if this function is y is equal to f of x, and if I want to write dy by dx, which you also call as f dash of x, of course, you know this, f dash of x can be written as dy by dx. So if you want to write expression for dy by dx, tell me. I told you dy by dx physically means for a given change in x at a point, what is the change in y correspondingly. So now if you see the change in x, see this is a and this length is x. So what could be the change? X minus a, correct? This is x minus a. Now let us write delta y, because we are writing in changes. No, we are not writing at a point anyhow. So let us write change in delta y divided by delta x. Okay, change in del y by change in x. So this change in y, see, for a corresponding change in x, you got a change of f of x minus f of a, correct? So this is f of x minus f of a, correct? This is what you got. Did you all understand this definition? How did I write this? Did you all understand how did I write this formula here? First of all, please tell me, did you all understand this? How did I write this? Yes? Good. So see here. If delta y by delta x is equal to f of x minus f of a divided by x minus a. Now, if you want to talk at a particular point x is equal to a, limit, continuity, all these all these definitions we are talking at a particular point. So if you want to talk this differentiability at this point, this x should tend towards this a. Then this curve keeps on shrinking and we'll be able to talk the differentiation at this particular point. Correct? So this x should tend towards a if you want to talk this differentiability of a function at a particular point. And that mathematically we write this as limit x tends to a. Limit x tends to a on both sides. Correct? Yes or no? If x is tending to a, then we can talk this about this part, limit x tends to a delta y by delta x at a particular point. And this mathematically it is written as f dash of x at x is equal to a, and this is instantaneous at a particular point. You have seen, correct? V average is equal to change in displacement divided by change in time, and instantaneous velocity is equal to ds by dt. Correct? Have you seen this? This is nothing but limit delta t tends to 0 will give you V instantaneous. Means within very small time, means within very less interval with at a particular point at an instant. And this is given by this definition, limit x tends to a f of x minus f of a divided by x minus a. And this is how we obtain the definition of a differentiation here. And what does this geometrically represent now? You see, this is something, and what does this geometrically represent? Can you tell me what does this geometrically represent? Slope of tangent at a point, and this value is nothing but slope of tangent to f of x at x is equal to a. At x is equal to a. Okay, and for slope, let us write something here. If this is 0, origin x and y, and suppose if this is your curve, something like this, y is equal to f of x, for example, then at this particular point, at this particular point a, if I want to calculate the slope, then I could draw on tangent here, hopefully with this color. I am trying to draw on tangent, so please try to make sure that this is a tangent to this function. If this is the tangent at this point, definitely this tangent will make some angle with this. Depending upon the shape of this function, this angle theta can be less than 90 or it can be more than 90, doesn't matter. Okay, but this tangent will be definitely making some angle. And if this is x is equal to a, if this is x is equal to a, then this f dash of a means f dash of x at x is equal to a, both are same, correct, is nothing but tan theta. And of course, if this point changes, the orientation of this tangent changes and this angle changes, correct? For example, if I am considering my a at this point, then tangent could have been much steeper, and this much flattener, so this theta could be a bit less in that case. So tan theta here in this case, and this theta will change depending upon this location of a. So did you all understand this part clearly? Please respond, yes or no. Did you all understand this part as of now? That slope represents this. Normally, if I ask you a straight line ax plus by plus c is equal to 0, what does this represent? It's an equation of a straight line. So what is this slope of this line? Straight lines have a slope which is constant. So please tell me what's the slope of this line? If theta is very small, okay, then slope will also be very small. Minus a by b, minus b by a, minus b by a, okay, minus a by b. Let us see what is this minus a by b or minus b by a. If you differentiate this equation with respect to x, if you differentiate this equation with respect to x on both sides, you have a plus b into dy by dx plus derivative of constant c is 0 and differentiation of right hand side is also 0, and which implies dy by dx is equal to minus a by b. Correct? This is what you have. So now if you convert this equation ax plus by plus c is equal to 0 to y is equal to mx plus c form, let us try to convert that. By is equal to minus ax minus c, and this implies y is equal to minus a by b into x plus minus c by b. And if you see, this is the slope of this line because it's of the standard form, slope intercept form. So y is equal to mx plus c. And if you see clearly, this slope which is here and the dy by dx value which is here, both are same. Correct? And you can also, so there is no confusion, it's minus a by b or minus b by a from the next time, but definitely you can differentiate the things because your differentiation gives you the slope. Clear so far? Is that okay? Did you all understand one point, that if you want to calculate slope at a particular point to any function, it's enough to calculate the derivative of that function at that particular point? Did you all understand this much? I want your responses. Please respond. Sir, all continuous functions are differentiable or no? No, actually we'll see. The next part is that. But did you all understand till this moment? If you understand till this part, we'll go ahead. Okay, so we'll go ahead. Now, your question, if function is continuous, could it be differentiable? Let us see. Let us take the example of mod x. Let f of x is equal to mod x, because this mod x function is, very common function that is asked in one of the exams. So we'll see, I mean in GATE exam many times. So we'll see this. Look, I told you, is this differentiable at x is equal to 0? Is this differentiable at x is equal to 0? Now this is the question. Now let us try to answer this question. Okay, now I told you for the function to be differentiable at a particular, no, of course, we'll see how. See, because it's a bit important and people who didn't attend my previous maths course, you'll get things here. So see, if f of x is equal to mod x, now is this function differentiable at x is equal to 0? Let us check. I told you the function f of x is said to be differentiable at this point if limit x tends to 0, f of x minus f of a divided by x minus 0. If this exists, then we will say mod x will exist. I mean, mod x is differentiable at x is equal to 0. If this limit does not exist, then we say mod x is not differentiable at x is equal to 0. Correct? Because I told you that for the function to be differentiable, this limit has to exist. So we are writing that limit for this particular case of mod x. Now, this is a limit. So whenever there is limit, it's obvious we need to check for both left hand limits and right hand limits. Correct? So we will see whether the left hand limit and right hand limit of this limit is same or not. Let us calculate the left hand limit. Limit x tends to 0 minus, because we are talking about left hand limit, so we'll talk about the neighborhood values which are to the left of 0. Mod x minus mod 0 is 0, known to you, x minus 0. This is equal to, look, if I want to remove this minus sign here, please be careful. This is the most important step in evaluating the limits. Whenever you are changing the limit, you should modify the function which is here. Okay. In yesterday's class also I remembered you, if you are changing this variable or if you are removing this neighborhood left or right, you need to modify this function. Now please tell me, limit x tends to 0, see here. If x is tending to 0 minus, please tell me one thing, x is more than 0 or x is less than 0? Please tell me this. If x is tending to 0 minus, then x is more than 0 or it's less than 0? It's less, correct? Because we told if there is something minus here, then we told that it's in the left neighborhood of a, correct? If this is less than 0, look, you told x is less than 0. This means what is mod x? This is minus x, correct? Because in yesterday's class I gave you the definition, mod x is equal to minus x for x less than or equal to 0, x for x greater than 0. This is the definition. Now you told this x is tending to 0 minus, which means x is less than 0. If x is less than 0, this mod x has to be replaced with minus x. Correct? Did you all understand this? Why this mod x has to be replaced with minus x in this particular limit? Did you all understand this much? Please tell me, did you all understand why mod x has to be replaced with minus x when x is less than 0? Yes, all of you, please respond. Yes. So which means this limit I can write limit x tends to 0. This time I'm not putting minus n here because I am modifying this function here. So minus x minus 0, anyhow it's minus x divided by x. X gets cancelled, and you know the answer for this limit is minus 1. Next, let us calculate the right hand limit. If I am calculating the right hand limit, limit x tends to 0 plus mod x minus 0, of course, modulus of 0 divided by x minus 0, and this is equal to limit x tends to 0. Now please tell me, I am removing this plus sign here, which means I am trying to generalize this limit. So limit x tends to 0, if I am removing this plus sign here, what shall I write in place of mod x? Plus x or minus x? Please tell me. It's only x. So x minus 0 divided by x minus 0, and you know this value is 1 anyhow. So we see this is 1. So you say the left hand derivative is minus 1. Of course, these are limits, but actually this is a derivative. So we call this as left hand derivative, and we call this value as a right hand derivative. Okay. So this is left hand derivative and this is right hand derivative. And you see both are not matching because this value is 1 and this value is minus 1. And you see left hand derivative is not equal to right hand derivative. Okay, so we say derivative does not exist. Derivative doesn't exist. But is mod x continuous at the same time? Yes, mod x is continuous. You can check left hand limit and right hand limit both gets equal for mod x, and functional value is also 0 at x is equal to 0. Okay, so if you see mod x is continuous at x is equal to 0, mod x is continuous at x is equal to 0, but not differentiable at x is equal to 0. And this statement, it's really important for us. Okay, because this question has been asked many times in many exams, so this point has to be made a note. Okay, now I'll show you the same result graphically as well. So please see here. If you try to draw the graph of mod x, if this is 0, this is x, this is y, and minus x, and this is minus y. So now see here, what could happen? If you try to draw the graph of mod x, this is how it looks for positive values of x, because you know y is equal to mod x is equal to minus x for x less than or equal to 0 and x for x greater than 0. You know this, correct? So since x is greater than 0, you know y is equal to x, and you know y is equal to x passes through horizon, making an angle of 45 degrees here, correct? Now for left hand side values of x which are negative, you know y is equal to minus x, and you know y is equal to minus x looks something like this, and this total angle is 135 degrees. Okay, and of course you know these two are perpendicular to each other. Now let us talk the geometrical meanings of the things. Look, you got limit x tends to 0 plus mod x by x, this value as 1, correct? Which is the right hand derivative, of course, right hand derivative. Now I told you derivative is nothing but slope of the tangent, and you know for a straight line the line itself is the tangent. So if you see this angle made by the line with the x-axis is 45, and for a straight line slope is constant, correct? If slope is constant for a straight line, and if this is making 45 degrees, what is slope on the right hand in the right neighborhood? Means in the right neighborhood means somewhere here. What is the slope of this curve? Slope is equal to tan theta, and you can see this is tan 45 degrees, which is 1. This result and this both are same, correct? Similarly, if you talk about the left neighborhood, if you talk about the left hand derivative, limit x tends to 0 minus mod x divided by x, and this value is equal to minus 1. This is what we got, correct? Similarly, if you see this total angle made here is 135 degrees. So if you want to calculate slope in the left neighborhood of this 0, means if you want to identify the slope of this tangent, you know this is making 135. See, you should always count in only in the positive sense. Okay, so this is 135 and slope is equal to tan 135, which is minus 1, and this is the result which we got from this evaluation of the limit previously. Here we got the left hand derivative as minus 1 and the right hand derivative as 1. So if you say this, geometrically the same thing gets evolved, and you know the function is not said to be differentiable at this point. But if you see, is there any breaking in this mod x graph? Did you see any breaking in this mod x graph at any point? Please respond. Did you see any breakage in this mod x graph from minus infinity to plus infinity? No, which means the function is continuous at this point x is equal to 0, of course at every point, but it's not differentiable at this point. So I hope I answered your question. Even though your function is continuous, it need not be differentiable. But for a function to be differentiable, the function has to be continuous definitely, because you see limit x tends to a, we have written this, correct? Yeah, here. If this x want to move towards this a, there should not be any breaking in between, correct? So for this, writing this definition, this function or this graph has to be continuous at every point. And at this point also we define the continuity of this function. Okay, so, oh sorry, I think, yeah, here. So one point is very clear. For a function to be differentiable, it should be continuous. Or you can write, for the function to be differentiable at a point, maybe that could be more clear. For the function to be differentiable at a point, the function has to be continuous at that point, definitely. Continuous at that point. But if the function is continuous, can you give surety for differentiability? Can you 100% say that it is differentiable? No, we can't say, correct? So this means for the function to be differentiable, it should be continuous definitely, but if the function is continuous, you can't say whether it can be differentiable or not until you perform the derivative test. Okay, means left hand derivative and right hand derivative. You will find, and if you equate both, if you feel that both the things are equal, you say that derivative exists, otherwise no. Clear so far? Now I would like to give you some key points regarding differentiability which could help you out in your exams. Okay, every function f of x is not differentiable at sharp points. Now what are these sharp points? Differentiable is not differentiable at sharp points. At sharp points. For example, if you see mod x graph turned out to be something like this, and here there is a sharp point, correct? There is a v, and here it is sharp. Okay, so this is one very good point, and your functions won't get differentiable at the points where there are sharp points for the function. Okay, x minus x, y minus y, and this is y is equal to mod x, and this fellow is a sharp point here. Okay, in general, you can write one more thing. Someone wants this screen. If you are watching on a mobile or a PC, you can take a screenshot. Hopefully, I'll move aside. Not only origin, there can be many points. I'll show you in example. We have one question for that. Rahul, don't worry, we'll work it out. Okay, so now we'll go for second point. If f of x is a polynomial function, then mod f of x is continuous at all points, or is continuous for all x belongs to R, means at all real numbers, but not differentiable at the points, where f of x is equal to 0. Okay, so you can see the function, if f of x is a polynomial function, then this function, which is, let me write a bit clearly, modulus of f of x. This function is continuous at all real numbers on a real plane, but it's not differentiable at the points where we are having this f of x is equal to 0. Okay, and third, the function f of x is equal to, or else you can write maybe h of x probably, which is f of x by g of x. Means it's a ratio of two functions basically, where f of x, this functions is not differentiable again, or even is not continuous itself, is not continuous at the points, is not at the points where g of x is equal to 0, because in the left neighborhood it may go to minus infinity and it may go to plus infinity on the other end. Okay, and of course g of x can be odd function, imprecise. To be, if you want to be clear, you can write g of x is odd function. You know what is an odd function and an even function? You can write f of minus x is equal to f of x. Then we say this is even function. See, since this is the revision class, I am not writing the complete terms, so please don't mind for that. And if this is minus f of x, then we say this is odd function. Okay. Side please. Okay. You want to write something? Okay. So far clear? See, at the end of, in the description of this video, I have provided the link for previous maths course which I have taken, and also we'll be displaying the topic that we did tomorrow. So if there is some time for you before coming to tomorrow's class, you please revise the particular topic in that course. Okay, I have given the link in the description anyhow. Okay. So can we start solving problems a bit? Because it's already in 10:40. It's been 40 minutes since we have started. So I hope this much theory could be sufficient. What is the difference between differentiation and integration? Integration is summing up actually. Differentiation is splitting, to be honest. Okay. So we'll see. And before going for the questions, I just wanted to tell you one thing. The first principle of differentiation, which is again a repetition of the formula that we have given. First principle of differentiation. First principle of differentiation. And of course, the function has to be continuous and all to be differentiable at a point. So I'm directly giving you the formulation for this. The derivative of any continuous function, f of x, the derivative of any continuous function, the derivative of any continuous function f of x is given by f dash of x is equal to dy by dx is equal to limit h tends to 0 f of x plus h minus f of x divided by h. This is what first principle of differentiation, but actually this is a repetition of what we taught. See here, suppose if this is x and y axis, and if we have a function something like this, which is y is equal to f of x, then if this is x, then definitely this is f of x. And if this point is, for example, if this is x plus h, then this point will be f of x plus h. Correct? So if you want the derivative at this point, at any point x in general, so f dash of x is equal to, what is the difference? Dy divided by dx. Dy is f of x plus h minus f of x is dy, change in y, divided by change in x is x plus h minus x, which is h. Correct? The difference between these two is h. Now we can take, since we are talking about a point, this x plus h should tend to this x. If x plus h is tending towards x, if I cancel x on both sides, which means h should be very small, means h is tending to 0. We write the same thing since we are talking at a point. Okay, limit h tends to 0 means h is very small. Then this differentiation we'll talk about at a particular point, and this is the formula for this, which I have stated here. And this is same thing like limit x tends to a, f of x minus f of a divided by x minus a, both are identical. There is no change. Clear? Did you all understand this? And you can find derivative of any function using this formulation. I mean, if you want a general formula, like for example, sin x, if you want to find what's the differentiation of sin x, you can use this formula and you can find. Okay. Anyhow, I'm not going to prove any results here, but I just wanted to show you the geometrical things. Okay. So now, there are questions. Okay, let us start solving few questions before going for the next parts. Now see here, the function f of x is equal to modulus of x plus 1 on the interval -2 to 0 is continuous and differentiable. Then there are different options, you can select one. Please try to answer this. And in GATE examination, one important thing I want to tell you now regarding GATE examination, in GATE always go for the most appropriate answer. Okay, for example, if they give you something like 2.6 plus 3.5 and option is equal to dash, I mean, in GATE they won't ask such questions, but I'm just giving you the idea of selecting appropriate answer. If the answers are something like 6, 7, 5, 8, if there are things like this, then this actual answer is 6.1. But out of the given options, this is much exact, I mean appropriate one to select. Okay, it need not be exact. It should be most appropriate out of these 4 options. Okay. Clear? Now what is the answer for this? Option B. Now I told you modulus of f of x. If this function is polynomial function, then this function is continuous at all points, but not differentiable at points where f of x is equal to 0. This is the point that I taught you, correct? So if you see, of course this x plus 1 is a polynomial, so this function is continuous at every interval. It doesn't matter it's -2 to 0 or something, but at every interval this function is continuous. So immediately you can eliminate two options here. It's given neither continuous. No, this function is continuous. You know this. So eliminate option C. Once read option D, differentiable but not continuous. Can this happen anywhere? For the function to be differentiable, definitely it should be continuous. But can there be any function that which is not continuous but it's still differentiable? Is that possible? No, correct? Which means you can also eliminate this option. Now, there are 2 options left with us, which is continuous and differentiable, continuous but not differentiable. Now, let us check for the points where this function is not differentiable. If you see, I told you these functions will not be differentiable at the points where f of x is equal to 0. So if you equate this x plus 1 is equal to 0, x is equal to -1 and this x is equal to -1 lies in this interval, correct? This x is equal to -1 lies in that interval, which means there is one point in this interval where this function is not differentiable, which means you can say this function is not differentiable on this interval. So the correct answer is B. The correct answer is B, but not A. Okay, because it's not differentiable at all points. Clear? Is that okay? So can I go for the next question, all of you? Can I go for the next question? Please respond. Yes? Okay, so we are going for the next question. This is the next question. What should be the value of lambda such that the function defined below? Okay, there is one function which is defined here. See, this is what we are talking about, split functions. If you put pi by 2 here, you will be getting 0 by 0 form. Function is not defined. So in such cases, they'll give some other value, defined value at that particular point. Okay, so this is what we told, during the definition of continuity. So please try to answer this. Okay, I think I'm blocking one of the options. Okay, so now you can see all the 4 options. So please try to answer this question and tell me what's the correct answer. Is it B? Option B? Look, let me tell you something. For f of x to be continuous at x is equal to A, for f of x to be continuous at x is equal to a, tell me one thing. I told you this condition should be mathematically satisfied. Limit x tends to a, f of x should be equal to f of a. Correct? Now, if you apply this definition here for this function, limit x tends to pi by 2, f of x should be equal to f of pi by 2. Now, please tell me one thing. All of you, if you understand yesterday's class, now you should answer this correctly. You should be in a position to answer this correctly. If I am writing limit x tends to pi by 2, f of x here, but here f of x is given as two different functions, lambda cos x divided by pi by 2 minus x and 1. This is the function when x is not equal to pi by 2, and this is the function when x is equal to pi by 2. Now, out of 1 and this function, what should I write here? Shall I, if I call this as a and if I call this as b, what should I write? Shall I write a or shall I write b in place of this f of x here? I should write a, correct? Because I told you if this limit is given, means if x is tending to pi by 2, then x is not equal to pi by 2, correct? I told you this. If x is tending to pi by 2, which means x is not equal to pi by 2 and there is a small difference between this pi by 2 and x always, correct? So which means this is the function we need to consider, lambda cos x divided by pi by 2 minus x. Now, this will give you 0 by 0 form. So if you apply L'Hospital within a single step, you will get lambda is equal to f of pi by 2, and when x is exactly pi by 2, this f of x value is 1. So this value is 1. C is the correct answer. Okay, clear so far? Did you all understand why did I write this lambda into cos x divided by pi by 2 minus x here? And did you all understand why C is the correct answer for this question? Yes or no? Yes? Please respond. I want all of you to get understanding. Fine. So let's go for the next question. This is the function. Consider the function f of x is equal to mod x in the interval minus 1 less than x less than 1. At the point x is equal to 0, f of x is, just now we have solved, mod x is continuous at every point, but it's not differentiable at the point x is equal to 0. So the answer is continuous and non-differentiable. C is the correct answer. Correct? Just now we have seen this. Do you all remember in the previous slides with graphs and all? I mean, yeah, somewhere here. Somewhere here, yeah. You told mod x is continuous at x is equal to 0, but not differentiable at x is equal to 0. And we have also graphically as well as mathematically seen this. Correct? So the correct answer is C. And this is the previous gate question. See, there will be many instances where a similar kind of question comes in many number of years, but I am not considering all those questions, okay? Because if I keep on considering that way, questions will be numerous and it won't be sufficient in this class. You know, time won't be sufficient in this class to solve all the questions, okay? So I'm picking every model, but I'm not repeating the same model kind of questions, okay? Is that fine to all of you? Is that fine? So can I move ahead for the next question? Yes. So this is the next question. So please try to answer. Which one of the following function is continuous at x is equal to 3? So they are given 4 options with 4 different functions. So you please try to work it out and tell me the answer. I'll be waiting for you. Please try to answer this question. Be audible because while drinking water I generally put off the mic. Okay, fine. So A is the answer, C is the answer. Okay, let us see what is the difficulty here. Solution. Let us check first option, option A. Okay, let us check whether this function is continuous or not. For continuity, left hand limit should be equal to right hand limit, and this also should be equal to functional value f of a. For example, let us call this as f of a. Now what is left hand limit? Limit x tends to 3. Actually it should be 3 minus and f of x, but since I want to write the exact function here, I am writing 3. And if I am talking about left hand limit, you know x is less than 3, correct? If I am talking about right hand limit, you know x is greater than 3, and of course if I am talking at that point, you know x is equal to 3. Now at left hand limit means when x is less than 3, out of these 3 functions, 2, x minus 1 and x plus 3 by 3, what should I substitute in place of x plus, in place of f of x? I should substitute this, correct? Because when x is less than 3 means when x tends to 3 minus, this is the function, so x plus 3 by 3. Let us calculate the right hand limit. Limit x tends to 3 when x is more than 3, this is the function, so x minus 1. And what is f of 3? At x is equal to 3 exactly, f of x is 2. So let us see whether these three are equal or not. I mean all these are equal or not. If you put x is equal to 3 here, this value is 2. If you put x is equal to 3, this value is 2. And here it is 2, and all are same, which means this condition is getting satisfied for the first option. So first option is the answer. Let us check for other options as well, B, C and D. We'll see, because few of you have also given C is the correct answer. So let us see B. Let us verify B. When x is not equal to 3, this is the function, so limit x tends to 3, f of x means 8 minus x, this should be equal to 4. Yes or no? Because limit x tends to 3, this value should be equal to 4. And if you see, this value is 5 and this value is 4, which is wrong. So B is not continuous. Similarly, if you go for C, when x is less than 3, you know the left hand limit value will be 6 and the right hand limit value will be minus 1. Can you sense it? If I calculate the limit, both left hand limit and right hand limit won't be the same. Left hand limit will be 3 plus 3, 6, and the right hand limit will be 3 minus 4, which is minus 1. Clear? So if you see, for option C also, left hand limit won't be equal to right hand limit, because left hand limit, if you put x is equal to 3, when x is less than 3 here, you will be getting 6, and when x is slightly more than 3, this 3 minus 4 will give you minus 1. So can you all sense it that C is not continuous? Can you all sense that this function which is in option C is not continuous because limit is not existing for this function? Got it? All of you, please say yes or no, please respond. Yes? Okay. Similarly, you can sense for option D, I told you when this polynomial tends to 0, for a given point, this function won't be continuous. So when you put x is equal to 3, this denominator goes to 0. So this function is not continuous. Okay. Because whenever denominator is 0, in the right neighborhood and left neighborhood, they go to plus and minus infinities. Function won't be continuous. Yes, in yesterday's class, we have seen y is equal to 1 by x. You remember? Since that's a simple example, I want to tell you. This is how the graph looks. So at the point where denominator is 0, these functions, they have a breakage. This point and this point, they are not connected. Okay. Similar is the case where for all polynomial functions, like I told you, f of x by g of x won't be continuous when this is equal to 0. Clear? Fine. So can I go for the next question? All of you, please respond. I'm going for the next question. Okay. So please try to answer this question. It's a simple question, basically a theory question. It was asked in GATE 2014. So please try to answer this question. If a function is continuous at a point, then we have 4 different instances here. So please try to guess the correct one. I will be standing a bit side so that you can see all the options clearly. First option is the limit of a function may not exist at that point. The function must be derivable at that point. The limit of the function at that point tends to infinity. The limit must exist at the point and the value of the limit should be same as the functional value at that point. Now what could be the correct answer out of this? I told you clearly, for continuity, this limit of this function at this point should be same as the functional value. Correct? So, and this option D is the exact English statement of this mathematical statement. Correct? So this is the condition for continuity. So, and these three are not the correct answers, because the limit of the function may not exist. Wrong, because if you want to show the function is continuous, definitely this limit has to exist. But it's given limit may not exist. No, limit should definitely exist. Second, the function must be derivable at the point. No, because if it's continuous, it need not be derivable. But if it's derivable, then definitely it should be continuous. We know this point. So this is also the wrong answer. And third question, the limit of the function at that point tends to infinity. No, because it should be a finite value, because you can't write infinity is equal to infinity. Okay, this is something which is not, we can prove. Okay, so D is the correct answer. Clear? I'm going for the next question. Are you all understanding the things, what's going on here? Please tell me, are you all able to understand what's going here? Yes? Okay, good. Then let us solve the next questions. If y is equal to 5x square plus 3, this is x square. I think 2 is small. So please make a note. Y is equal to 5x square plus 3. Then the tangent at x is equal to 0, comma y is equal to 3 is, these are the 4 options given. You can work it out. It's a simple question. You can work it out. So please try to work it out. Given function is y is equal to 5x square plus 3. It's again a question from GATE 2014. Erika, which country are you from? Or which state are you from? C is the correct answer. Is parallel to x-axis? I hope so. Let us check this. Look, if you want to know, see, if you see, options are something about slope, correct? Parallel, and also of course this is to the point. Now let us check. What is dy by dx? 10 into x, because differentiation of 5x square is 5 into 2x. So it is 10x. Okay. So if this is the case, now what's the point given? What is the tangent at this particular point? So 0, 3 is the point where you need to find the nature of the tangent. Correct? So if this is the point, dy by dx is equal to 10x, then dy by dx at this point 0, 3 is 10 into 0, which is 0, which means slope is equal to 0. This thing is very clear. Slope is equal to 0. If slope of any curve is, or any tangent or any straight line is 0, then what could be the line? How could the line look like? The line has to be parallel to x-axis, because two parallel lines always have the same slope, and the slope of this x-axis is 0. So if there is any line which is parallel to x-axis, then definitely the slope of that particular line has also to be 0, and that's what we got here. So if slope of 0, then if slope of this curve at this point is 0, then definitely the tangent is parallel to x-axis. Now if you don't know that mathematically, geometrically, slope of the tangent is nothing but the derivative, then you can't solve this question, correct? Because you know the function and you don't know the tangent and slope are, slope of the tangent and derivative are interconnected to each other, then you can't answer this question. Clear? So that's why you need to geometrically know that slope geometrically denotes the, derivative at a point geometrically denotes the slope of tangent at a particular point. Clear? Is that fine so far? Yes, I expect reply from all of you, because it's not like if few of you are understanding, that's okay to me. Okay, all of you should understand this. Okay, so we'll go for the next question. This is the question. The function f of x is equal to x into sin x satisfies the following equation. F double dash of x plus f of x plus t into cos x is equal to 0. Then the value of t. This is t into cos x. The equation is something like this: f double dash of x plus f of x plus t times of cos x. This is actually 0. Now what is the value of this t? And this f of x is given as x into sin x. So please calculate the derivatives and try to substitute in this equation and try to get the value of t. I again request you, if you are liking the session, please hit the like button, because if you are if the likes versus dislikes ratio is high, then it gets shared to most of the people. And also please share the video. Okay, since we are not charging anything for this, it could be of help to many others. Rajkumar, you want for the previous question why it's C? Because you know slope is 0 and you know slope of x-axis is 0 and slope of any line, you know tangent is a straight line, so slope of any line parallel to x-axis is 0. Okay, so that's why. So finally, what's the answer? -2. So let me check. Let us calculate f dash of x. What is f dash of x? When there are two functions, in yesterday's class, I have already mentioned, when there are two functions, f of x into g of x, the differentiation of this product combination is first function into derivative of second function plus derivative of first function into second function. So if you adopt this particular formulation here, the function is x into sin x. So first function into derivative of second function, which is cos x, plus derivative of first function, which is 1, into second function sin x. So this is x cos x plus sin x. Now what is f double dash of x? If this is x into cos x, then the differentiation of this x into cos x is x into derivative of cos x is minus sin x, plus differentiation of this x is 1 into cos x, plus differentiation of this sin x is again cos x. So this is what we have for this. So let me shorten this a bit. Okay, so now try to see here. So if you substitute this f double dash of x and this f of x in this equation, let us see what happens. This implies f double dash of x, which is minus x sin x plus 2 cos x, plus f of x. F of x is x into sin x, plus t cos x, t times of cos x is equal to 0, which means this x sin x and this minus x sin x gets cancelled, and you know 2 cos x plus t cos x is 0, which means t has to be minus 2. See, when I shortened, you got the answer minus 2 here. Okay, fine so far. Are you all able to solve this question, and can you find the value of t is minus 2? Okay, so before going for next questions, I would like to give you a few differentiation formulas, because see, we are writing derivative of sin x is cos x and all, so there might be many job holders who might go out of academics for quite a long time, so there can be a chance you might be forgetting these differentiation formulas. Okay, so I'll give you a few differentiation formulas. You try to get habituated with them, not in a single go, but gradually you will get to familiar with them. So let me write some standard differentiation formulas that could help you. Some standard derivatives. Before I proceed for the next questions, because it could help you out in some way. Some standard derivatives. First one, let us start with trigonometric functions. Derivative of sin x is cos x. I'm not asking anything, so you please try to write with me, because this is a revision course, so I don't want to spend much of the time in simple things. Minus sin x, derivative of tan x is secant square x, derivative of cot x is minus cosecant square x, derivative of secant x is secant x tan x into tan x, secant x into tan x basically, and derivative of cosecant x is minus cosecant x into cot x. Okay, please make a note, there are two minus signs here and here. So now the basic trigonometric ratios are done, so let's go for the inverse trigonometric ratios. So 7 d by dx of sin inverse x is 1 by root of 1 minus x square. See, please write these formulas very carefully, okay, because if you make a mistake, some mistake while copying with the minus sign, your answers may go wrong in exam. So please, I request you, don't write anything wrongly. Okay, don't copy something wrongly. Please write well. Okay, so 8 d by dx of cos inverse x is equal to minus 1 by root of 1 minus x square, and derivative of tan inverse x It's not mandatory that you'll remember all these formulas by today's class itself. Slowly, if you keep on using, you'll be getting with the things. So next formulas, d by dx of cot inverse x is minus 1 by 1 plus x square. Let me write this because this green line is excess here. Minus 1 by 1 plus x square. Okay. Next, 11. D by dx of secant inverse x. 1 by mod x into square root of x square minus 1. And similarly, d by dx of cosecant inverse x is equal to minus 1 by mod x into square root of x square minus 1. Okay. Yeah, I'll provide notes of every class in Telegram channel. So that's why I have asked you, please subscribe to the Telegram channel. Okay. So if you have subscribed into the Telegram channel, definitely you'll be getting the notes after class. Okay. So 13. So trigonometric and inverse trigonometric functions are finished. Let's go for the algebraic functions. See, you are getting a Telegram link. Link for the Telegram channel in the chat box. So you can click that and you can join. Okay. So next we'll go for algebraic functions. D by dx of x power n is equal to n into x power n minus 1. Okay. 14. D by dx of a power x exponential functions. Let's go for exponential functions. So this is a power x into log x to the base a. Multivariable limits will solve. See, this is single variable calculus. Okay, we are right now dealing with single variables. When we go for multivariables, definitely I'll teach how to find two variable limits. Okay, Mahesh, no need to worry. Next, 15. D by dx of e power x. I'm sorry a bit. This should be log a to the base e. Okay, so please make a correction. This is log a to the base e. Okay, yeah, correct. Yeah, what you told, it's correct. Sorry, it is a power x into log e. So the derivative of this is again e power x, because if you replace a with e, differentiation of e power x is equal to e power x into log e to the base e, which is 1. So the answer is e power x. Okay, next. Exponential functions are also completed. Algebraic. I want to give you one more function, x power x. What's the answer for this? D by dx of x power x. Logarithm to the logarithm of a to the base e. Okay. Is there 50% speed button? Okay. Good, but actually this is a revision course. Okay, we have already covered all these things in the comprehensive course. So difference between log and ln. If you write log x to the base e and if you write ln x, these both are same. Okay, but generally if you write log x without mentioning anything here, this actually means log x to the base 10. Okay, log generally you write for base logarithms and ln for natural logarithms, for which base is e. Okay, this is the difference. X power x into 1 plus log x to the base e and d by dx of log x to the base a is 1 by x into log a to the base e. This is the derivative. So differentiation of ln x is 1 by x itself, because this value turns out to be 1 whenever the a is e. Okay. So I hope you got inverse functions, logarithmic functions, algebraic functions, trigonometric functions, and also exponential functions. Clear? So I'm again telling you, if you are liking the content that's being shared here, you please like and share this video, and also subscribe to our channel to get notification of the future courses that we offer here. Okay. So I hope these 17 formulas could help you out at some point in your mathematics at different subjects. So please let us continue solving the questions. Okay. So please try to answer this question. So please try to answer this question. And to get the link of this full course of mathematics, which I'm telling you that I have already covered it, it's in the description box of this video. You can have a click over there after the class. See, you are getting two different links in the chat box. One is for mechanical students and another is for rest of the students. So you can click the link and you can subscribe the channel if you haven't done it yet, so that you'll be getting the notes of the class every day. So few people are telling it A and one is telling it C. What's the correct answer for this? C? Only 2 replied. What about others? C. Okay. Many of you are telling C. Only 5 people have responded. What about others? C. Okay. So let us see. The value of x, or the values maybe for which the function f of x is equal to this function which is given here is not continuous. I told you if you have some f of x by g of x function, then I told you this function won't be continuous at all points where this is 0. So which means this function is not continuous. F of x is not continuous. Not continuous at the points where you know this denominator, basically this denominator. Let me change the ink color so you can see it. This denominator, x square plus 3x minus 4 is equal to 0. And if you solve this quadratic equation, you should get minus 4 and 1. I hope you know how to solve the quadratic equation. So if you solve this, you will be getting this values as minus 4 and 1, which is option C. Okay, because sum of the roots has to be minus 3, which is only possible in this case. So since this is a multiple choice question, one answer should be definitely correct. So I hope that could be the correct answer. Anyhow, if you solve, you'll be getting the same answer. You can factorize, or we have different methods for finding roots of a quadratic equation. So you can do any one. Yeah, C is the correct answer. I'm happy that many of you are answering the things correctly. So can I go for the next question? I hope it's 8th question. So we have few more questions left. And what's the time, by the way? It's okay. Let me not do this. Let me do this. 11:16. Okay. Yeah, it's 11:16 IST, of course. So let us go for next questions. Is that okay to all of you with this question? Please respond. Is it okay to all of you with this question? Okay, so I'm going for the next question then. This is the next question. Previously, few of you have asked at sharp point means will sharp points always come at x is equal to 0 only? I told no, I'll be showing one example, and this is the example. It's not necessary that sharp points will always come at origin. It can come at many other points. So see here. The function f of x is equal to modulus of something where, of course, this L is some positive value and x is the complete real numbers plane. Is continuous and differentiable, not continuous and not differentiable, not continuous but differentiable, continuous but not differentiable. Okay, there are 4 combinations with this continuity and differentiability. So let us, try to find it out. I told you mod f of x is continuous at all points. Continuous for all x belongs to R. But this is also not differentiable for the points, not differentiable at the points where f of x is equal to 0. Correct? If this is the case, then this function is continuous at all points, but it's not differentiable at the points. Not differentiable at the points where sine 2 pi x by L is 0. Correct? And if you see at x is equal to 0, this value is 0 definitely, because if you put 0 here, sine 0 is 0, and this f of x gets to 0 at x is equal to 0. So you can say the function is continuous, but it's not differentiable. So option D is the correct answer. Continuous but not differentiable at x is equal to 0. Correct? So let me try to draw the graph of this function, because yesterday many of you are asking how to draw the graphs and all. So let me try to draw the graph of this function and let me show you. Okay, since we have some time, let us utilize that time for that. Look, I'm telling you how to draw a graph of any given function. Okay, I have already told it. I have already discussed this in my previous course, but again I would like to tell it now. So see here. First of all, first step is you set up the axis. Okay, 0, x, minus x, y, and minus y. Okay, and yeah, for all mod functions, if inside, yeah, of course it have some function inside the modulus basically. F of x is equal to, write this function, y is equal to f of x. Now, try to find the maximum and minimum values of this f of x. Maximum and minimum values of f of x. Try to find this. Minimum values of f of x. Now, whatever can come here, this sign of this something will always lie in between minus 1 and 1, correct? Because sin x function is such kind of function, whatever the kind of input you put in place of this x or in place of this variable, this sign will always give you the same output, which means this sign value will lie always in between minus 1 and 1. But here we got a modulus also for this function, correct? If there is a modulus place bounding the function, then this function will always give only positive values, which means when this sin x is having all values in between minus 1 and 1, this mod of this sign of this something will give values only in between 0 and 1, correct? Which means the maximum value of this function is 1 and the minimum value is 0. Did you all understand why did I write 0 and 1 as minimum and maximum values respectively? Did you all understand this? Why I have written 0 to 1 as minimum and 0 and 1 as minimum and maximum values of this function? Because sin x, see, sin x or sin y, maybe if you call this function not even y, sin v, for example, since my name is Vinay, let us replace this with v. Whatever might be the value of v, sin of this thing will always lie in between minus 1 and 1. Correct? So if you apply modulus, this sin v can't be negative. So 0 less than or equal to mod of sin v is less than or equal to 1. Okay, so that's how the lower limit of this function is 0 and the upper limit is 1. So first of all, identify the limits and plot them. Now, this is y is equal to 0 anyhow, x-axis, and this is y is equal to 1. This is the second step. Okay, you need to find the maximum and minimum values of the f of x. Next, you should look for repeating patterns. Means for example, if there is sin x, sin gets repeated after every 2 pi intervals. Similarly, tan gets repeated after every pi interval. So if you see, you should look for the repeating patterns. So if you see there is sin here, so something is repeating. It should repeat. It can't go below this because this is one boundary for this function. And whatever the graph you draw, now you should draw only in between these two lines. So this gets repeated. Similarly, here. So this is how the graph of y is equal to sin 2 pi, of course, modulus of sin 2 pi x by L looks like. Okay, and what about these points now? If you talk about these points, this sin x will give you 0 if this is pi. For this 2 pi x by L to be equal to pi, x should be equal to L by 2. So this is L by 2. Again, this is L. This is 3L by 2. Similarly, this is minus L by 2 and all. So this is how the graph of sin 2 pi x by L, of course, this line I think it's going cross, but it should be straight actually. Okay, because maximum values are same at every instant. All these are to be equal actually. Okay, so this is how you generate graph of any function, and this is a sharp point here. Function is not continuous. Not differentiable at this point. Okay. And this implies function is not differentiable, is continuous, but not differentiable at x is equal to 0. It's also not differentiable at x is equal to L by 2, L, 3L by 2 at all these points, correct? So if you see, this function has infinitely many sharp points because it's given this x is running from minus infinity to infinity. So within the long range of these real numbers, there comes infinitely many points where this function takes sharp points. Clear to all of you why this function is continuous but not differentiable at x is equal to 0? I'm expecting some replies from you, all of you. Is that okay? Is this understandable to all of you? Yes? Okay. Then we'll go for next question. Right? Yeah. This is the question. Given the following statements about a function f from R to R from real numbers plane to real numbers plane, select the right option and you have few options. Statements here P, Q, R. Now we need to decide out of this P, Q, R which statement is correct and which is not. Out of these three statements, please decide. Okay, side please. Fine. This is some lengthy question, I guess. Okay. This question was asked in 2016 for TRIPLE and ECE. So the correct answer is B. That's what you are telling, many of you. Okay, so see here. What are the functions? I mean, what are the statements P, Q, and R? If f of x is continuous at x is equal to x naught, okay, if function is continuous, then it is also differentiable at x is equal to x naught. No, need not be, correct? It need not be differentiable. Example, we have seen mod x. It is continuous at x is equal to 0, but it's not differentiable at x is equal to 0. So P is false. So you can delete the statements where it was written P is 2. So you can delete this statement also because it's written P is 2 here. Correct? But P is false. So A and D are not answers for this question. Next. There is no use of checking Q because Q in both the options it's given 2. So let us check for R. What is R? If f of x is differentiable at x is equal to x naught, then it is continuous. 100%. Correct? Because I told you if the function is differentiable, it should be definitely continuous. So it's given if the function is differentiable, it should be continuous. Yes, it's correct. So R is 2, which means this option is wrong. So B is the correct answer. Okay. In gate examination, you should try to eliminate few options. Okay. It's not like solving the question completely and then you need to answer. Okay. With your basic idea on the question, you should be able to, or you should be in a situation to eliminate few options. Okay. But anyhow, this is a simple question, so there is no issue. But this approach will be helpful for you in future topics of mathematics or maybe in your own core subjects. Okay. So I hope I can move for the next question. Many of you have answered this correctly. Fine. So can I move for the next question? All of you, please respond. Okay. This is a question from civil engineering in 2016. So see, the angle of intersection of the curves x square is equal to 4ay and y square is equal to 4x. So let us talk about something before we go for this question. Look, if two curves are cutting, for example, if this is y is equal to f of x and if this is y is equal to g of x, for example, if these are two curves and if these two curves are intersecting at a point A, for example, then if you want to know by what angle they are intersecting, let us see. First of all, try to draw the tangents for these two curves, or else let me use some other color because yellow and green they are looking, most similar. So let us draw tangents to these two curves. This is tangent for the function f of x and this is tangent for the function g of x. Okay, g dash of x actually. Now you want this angle theta, which is the angle between the tangents. This angle is the angle with which these two curves are cutting at this point A. Okay, and to do that, you should know what is this point A, x comma y. Or else, for example, let us write a comma b for better understanding as of now. A comma b, which means you should find what is f dash of x at x is equal to a, and you should also find g dash of x at x is equal to a. Then you will be getting the slopes of these two tangents. Now, if there are two straight lines of which slope of one line is m1 and slope of other line is m2, and if this is theta, can you give the relation between theta m1 and m2? If there are two straight lines of which one line slope is m1 and the other is m2, and if theta is the angle between them, can you give me the relation between theta m1 and m2? m1 into m2 is equal to -1. Need not be mandatorily, but I am giving you the expression. I don't want to derive this since this is of some basic level. So you can see tan theta can be written as, for acute angle, m1 minus, means if you want this tan theta, I mean theta to lie in between 0 and 90, generally we consider the acute angles. So we'll put a modulus m1 minus m2 divided by 1 plus m1 m2. This is the relation between theta, m1 and m2s. Okay, so this is what we have. If there are two lines with slopes m1 and m2, then which are bounded, I mean which are with an angle difference of theta, then tan theta is given by this. So if the two lines are parallel to each other, you know, if two lines are parallel, then this theta will be 0, correct? Because if two lines are parallel, they won't intersect at any point. So if you put theta is equal to 0, the left hand side becomes 0, which means in this expression, this right hand, the numerator has also to be 0, which means m1 should be equal to m2, correct? So for two lines are parallel, if two lines are parallel, then their slopes are equal. Similarly, if two lines are perpendicular, you know, if this angle is 90 or tending to 90, tan 90 is very huge, infinity, correct? It's a very big number. So for that to happen, this denominator has to be very small, which means this 1 plus m1 m2 should tend to 0, which means this m1 into m2 should tend to -1, which means if two lines are perpendicular, the product of their slopes tends to -1. Clear? Similarly, if two lines are parallel, their slopes will be same. Is that clear to all of you? Did you all understand this theory till this point? Did you all understand this theory till this point? Okay, so if that's the case, we will try to solve this question. Look, the angle of intersection of the curves x square is equal to 4y. Solution. One curve is given as y is equal to x square by 4. Okay. Second curve is given as y square is equal to 4x. Now, first of all, you should find the point of this intersection. Correct? So if you want to find the point of this intersection, let us see. This is 0, x, y, this is minus x, this is y, and this is minus y. Now, you know, y square is equal to 4ax. How does y square is equal to 4ax looks like? It looks something like this. Y square is equal to 4ax. Next, similarly, x square is equal to 4ay. Also look, okay, let me use a different color so you can identify the two graphs separately. Something like this. Okay, this is x square is equal to 4ay. Now, you know, both these are intersecting at 2 points, of course, this and this, but of course we are interested at this point 0, 0. So here, now, yeah, some other points, there is one more point here, but in the question we are interested at this point of intersection 0, 0, correct? So if this is given, then the tangent to this x square is equal to 4ay is nothing but this x-axis. Correct? Similarly, tangent to this y square is equal to 4ax is nothing but this y-axis. So what is the angle between these two tangents? 90 degrees. This is what you can see here, option D. Okay, if you don't know the diagram, still you can solve this question. Find the derivative here. Y dash is equal to 2x by 4, which is x by 2. But since we want the slope at this point where x is equal to 0, the derivative is 0 at this point. Here, 2y into dy by dx is equal to 4, and which implies dy by dx is equal to 4 by, or else you can write 2 by y. And since we are talking at the point 0, 0, this is 2 divided by 0, and this tends to infinity. So if you see, slope is 0, which means this here the tangent is parallel to x-axis or the x-axis itself, and here the tangent is parallel to something like y-axis, which means these two lines are perpendicular to each other. So the angle between them is 90 degrees. Okay. Because I told you slope is nothing but tan theta. Correct? Angle made by the tangent. So if you see, if this is 0, then the angle made by one of these tangents is 0, and you can see x-axis is one of the tangents to this both curves. I mean, is tangent to one of these two curves, and similarly y-axis is also tangent to one of the two curves, and the angle between them is 90 degrees. Clear? Did you all understand this question? Did you all understand this question? Oh, this PPT is tilting. Okay, let us keep it like this, 5i. Okay. Is that okay? This is the mathematical way and this is the geometrical way. You can solve in any of the ways that's available. Fine. We are going for the next question. This is the question, 12th question. It was asked in 2017 for electrical engineering people. So let me put this. Yeah. For 2017, I mean for people, electrical engineering in 2017. So please try to answer this question. A function f of x is defined as f of x is equal to e power x when x is less than 1 and some other function when x is greater than or equal to 1, where x belongs to real numbers. Which one of the following statement is true? Out of these 4 statements, which is true? You should be able to answer this question. So please try to answer this question. F of x is a split function. It's defined something for x less than 1 and it's defined as some other function for x is greater than 1. Then which of the following 4 options is true? This is a good question actually. So I want you to solve this question before I reveal the actual answer. Please try to answer this question. I'll give you just 2 minutes of time. Okay. Option B, f of x is differentiable at x is equal to 1 for unique value of a and b. And some other is telling option C for all values of a and b such that a plus b is equal to e. Again one b and one c. Again there is one b. Okay. So let me try to solve this question. Look, for the function to be differentiable, should it be continuous or not? Please tell me. For the function to be differentiable, should it be continuous or not? Yes. Good. So it should be continuous for the function to be differentiable. And if the function has to be continuous, then definitely this left hand limit and right hand limit should be same, which means for differentiability, because here all the 4 options are talking about differentiability, so let us talk about this. For differentiability, limit, function should be continuous. Function should be continuous, which means its limit should exist. Function should be continuous, which means its limit should exist. And if you write its limit should exist, limit x tends to 1 e power x should be same as limit x tends to 1, right hand limit ln x plus ax square plus bx. This should be the required condition. So this implies if you substitute x is equal to 1 here, e is equal to ln 1 is 0 because logarithm of 1 with any base is 0. So this is 0 plus a plus b. So a plus b is equal to e. But question is not yet finished. For continuity, A plus B should be equal to E. Means the function is continuous for any set of values where A plus B is equal to E. But in question, he is not asking about continuity, he is asking about differentiability. Correct? So let us see. F dash of x, see, f of x is equal to e power x when x is less than 1 and ln x plus ax square plus bx when x is greater than or equal to 1. This is what it's given in the question. Correct? If I'm not wrong, yeah, this is what it's given in the question. So can I write f dash of x is equal to e power x, because derivative of e power x is e power x itself when x is less than 1. What's the derivative of this function? 1 by x plus 2ax plus b when x is greater than or equal to 1. Correct? These are the derivatives. Now, if this function has to be differentiable, both left hand limit and right hand limit of this should be same. Correct? So let us write left hand derivative should be equal to right hand derivative for differentiability, which means left hand derivative means limit x tends to 1. The left hand derivative is this given by this function, and the right hand derivative is given by this function 1 by x plus 2ax plus b. Let us simplify this. E is equal to, if you substitute 1 plus 2a plus b. So we have two equations and two unknowns. This is first equation. Yeah, this is second equation, and this is first equation. Now, if you solve these two equations, you will be getting one unique set of a comma b for which this function is continuous and then differentiable. Correct? I think if you solve, you will be getting something like a plus b. So a is equal to -1, and if a is equal to -1, then b should be e plus 1. These are the two set of values, one set of values of a and b where this function is differentiable. Correct? You can even check the differentiability in this way. You can first of all differentiate the functions, then you can find limits. Okay, or else you can write. Okay, let us not assume that it's differentiable. Okay, yeah, see here. Now it's continuous. Now we can apply this limits and see whether these limits are existing or not. F of x, so e power x minus 0, this is e, f of x minus f of a divided by x minus a. You can check this limit. Similarly, you can also check this limit. Limit x tends to 1, f of x, which is ln x plus ax square plus bx minus ln 1, which is 0 plus a plus b divided by x minus 1. You can see, and you can equate these two for the condition, assuming that the function is differentiable. Both are identically same. Okay. Anyhow, since in the options it's given differentiable or not differentiable, we can't differentiate directly, so you can use this even. Both are identical. Okay. Normally, if you want to find whether a function is differentiable or not, you can find the derivatives and you can check the limits. If limits are same, then your assumption is correct. If your limits are not same, then your assumption is wrong, which means the function won't be differentiable. Okay. So can I go for the next question? Okay, Suhas. Since that is easier to calculate, calculation is a bit simple, I have directly differentiated this. Okay, there's nothing big thing that's happening. Okay, so see here. Oh, this is the case, 13th question. It was asked again for civil engineering in 2017. So see here, the tangent to the curve represented by y is equal to x into ln x. You need to find what's the tangent of this curve. Not differentiable one. Venkat sir, you have some doubt? Okay, please let me finish this question. I'll get back to you. The tangent to the curve represented by y is equal to x into ln x is equal to have 45 degrees inclination. Means, see, the tangent is set to have 45 degrees inclination, which means what should be the slope? Look, at some point, the tangent of this curve is expected to have 45 degrees inclination with x-axis, which means what should be the slope of this curve? Please tell me. 1. Correct? Now let us differentiate this function. dy by dx is equal to, differentiation of this function is x into 1 by x plus ln x, and this is equal to 1 plus ln x. And you know, dy by dx at a point is nothing but slope at that point, so you can equate this value to 1, which implies ln x is equal to 0, and this implies x is equal to 1, which means the point at which you are talking about the slope to this curve, the x coordinate of the point is 1, which is not present in both these options, so you can delete them. Okay, so if you see, the x coordinate at which the slope is 1 for this particular curve is 1. So one of these two options is correct actually. So if x is equal to 1, you can find the value of y by substituting in this equation. So y is equal to 1 into ln 1, and this ln 1 is 0, so y value is 0, because the point x comma y should lie on this curve, correct? Because it's given the tangent to the curve represented at a point. So the answer is 1 comma 0. You're getting y is equal to 0 and x is equal to 1. Okay, because this is the point at which the slope of tangent to this curve is 1, which means the tangent is making a 45 degrees inclination with x-axis. Okay, so shall we go ahead? Oh, Venkat Sai, I forgot this thing. Yeah, normally doing it this way means you can write limit x tends to a f of x minus f of a divided by x minus a, and you can check left hand derivative and right hand derivative. Or you can assume that this function is differentiable and you can check the limits which I have written in previous case. If these two are equal, your assumption is correct that this function is differentiable. If these two are not same, you can't say that this function is differentiable. So that's how you can check whether a function is differentiable or not, either by writing the basic formula like this or by assuming that the function is differentiable and then finding the limits. Both are same, okay, but in the later part generally calculations will be a bit low, so I directly used that. Okay, Venkat, so now let's go for the next question. 14th question, 2018 mechanical. If f be a continuously differentiable function, continuously differentiable real valued function defined by f of x is equal to these two values, the value of a square b is dash. So some function is given, you want to find a square b. This question was also asked in XE last, 2019 or 20. So please again try to calculate the values of a and b by identifying two equations for a and b. First of all, if it's continuously differentiable means it's also continuous and it's also differentiable, and second derivatives, third derivatives, all they are existing. 250 is the answer. All of you, please try this. Even if you are doing it a bit late, I don't bother, but please try genuinely. Okay, even if you're not getting the answers, that's okay, but please try, put an effort. 250. Okay, all of you are getting 250. So let us try to solve this question. If it's differentiable, then definitely limit should exist. So limit x tends to 1 bx plus a is equal to limit x tends to 1 5x square. This means your a plus b is equal to 5. This is one equation that you are getting. Okay, again if it's differentiable, limit x tends to 1, what's the derivative of left hand function? B is equal to limit x tends to 1, what's the differentiation of the right hand side function? 10x. So this implies b is equal to 10x and this value is 10. So b is equal to 10. So a is equal to minus 5 from this equation. So a square b is minus 5 whole square into 10, 25 into 10, which is 250. Correct. See here, there is small portion of 2 which you can see, and 5 and 0. Okay. Okay, now I hope you are able to see 250 there at the right bottom. Acha, this is again tilting. Okay, let's leave like this for now. Okay. So did you all understand it's how it's 250? No, still you can't see that there is 250. It's okay, fine. So can we go for the next question? I think this is a bit tilted, correct? So let me tilt this a bit, Anyhow, I'm not a good Ziegler to maintain balance, but of course, I can still try to maintain somehow. Yeah, better, far better. This is one question that was asked maybe in 2018 TPE. Oh, sorry. Yeah, 2018 TPE. So please try to answer this. Please try to answer this question. Let f be a real valued function of a real variable defined by f of x is equal to x square for x greater than or equal to 0 and f of x is equal to minus x square for x less than 0. Which of the following statements is true? Please explain once more. Previous question, Suhas. Okay, let us complete this question and then we'll go for the last question. Next question. Previous question. Okay. What's the answer for this? Option B. Option B due to what is CUSP Uganda? This question B. Okay, this question answer is B. That's what you are telling. F of x is continuous but not differentiable at x is equal to 0. Let me check. Modulus property. Answer is D. See, what's the answer? This is a very good question and actual answer is D, I guess. Okay. So let us try to solve this question. This is a really good question and please stay tuned till the completion of this question. Don't leave in between because this question is a really good question. See, f of x, if you try to write this function, x square for x greater than or equal to 0. Okay, first of all, let us write minus x square for x less than or equal to 0. Okay, less than 0 and x square for x greater than or equal to 0. This is what you have, correct? So let me use this in the next steps. F of x is equal to minus x square when x is less than 0, x square for x greater than or equal to 0. This is what you have, correct? So now, what could be f dash of x? Suppose if we assume that this is differentiable, or let me go straight away. Let me not use any shortcuts. Let me calculate. Let us check the continuity of this function. First of all, for the function to be continuous, this should happen. This condition should get satisfied, correct? So let us see whether we are getting this condition or not. Which means limit x tends to 0 minus f of x. This should be equal to limit x tends to 0 plus f of x, which should also be equal to f of 0. So let us see whether this thing is happening or not. Limit x tends to 0 minus f of x, we can write this as limit x tends to 0 when x is tending to 0 minus, which means when x is less than 0, this f of x is minus x square. So minus x square is equal to limit x tends to 0 plus means limit x tends to 0, and when x is tending to 0 plus means when x is more than 0, this f of x is x square. And f of 0, you see equal to sign is maintained here. So if you see at x is equal to 0, the function is again x square. So f of 0 is 0. And if you see, this condition is true because if you substitute 0, this is 0, this is also 0, and this is also 0, which means this function is continuous. So one thing is clear, this function which is written here, f of x, is continuous. Now, let us talk about the first derivative of this function. Let us see whether the first derivative of this function is existent or not. Let us assume it is existent. So f dash of x is equal to minus 2x when x less than 0 plus 2x when x is greater than or equal to 0, correct? Because derivative of this minus x square is minus 2x and derivative of this x square is 2x. Now let us see whether the left hand derivative and the right hand derivative are equal or not. Okay, so let us check this. What is the relation between these two? What is the left hand derivative? Limit x tends to 0 minus 2x. Similarly, what is the right hand derivative? Limit x tends to 0 plus 2x. And you know, both these are same. They are equal, which means this first derivative is existing. So we can say f dash of x at x is equal to 0 exists. Now, let us check for the second derivative. F double dash of x is equal to differentiation of this minus 2x is minus 2 when x is less than 0. Differentiation of this 2x is 2 when x is greater than 0. Now, is this second derivative existing? Please tell me, because if you apply left hand limit, the answer is minus 2, and if you apply the right hand limit, answer is 2. So please tell me, is this second derivative existing? No. Correct? This second derivative is not existent, which means, yeah, first derivative is existing, but second derivative is not existing. So this doesn't exist. But the function is continuous and the first derivative is existing. So let's get back to the options. F of x is discontinuous at x is equal to 0. Is this correct? No, because we have seen clearly the function is continuous. So this is wrong. Second, f of x is continuous, okay, but not differentiable at x is equal to 0. No, this is wrong. We have seen the first derivative is existing. So f of x is continuous and it's also differentiable at x is equal to 0. Let's go for the third option. F of x is differentiable, okay, but its first derivative is not continuous at x is equal to 0. First derivative, if you see, it's continuous actually. That's what we have seen here. See, it's continuous at x is equal to 0 also. This value is 0. So this function is continuous actually. Correct? Suppose if you treat this f dash of x as g of x, then this g of x is continuous. Yes or no? Can you feel that if I call this first function as g of x, this g of x is continuous at x is equal to 0? Can you all sense it? Yes or no? Please tell me. If I call this function as g of x, then this first derivative means this function is continuous at x is equal to 0, which means this is also wrong because it's given not here. And finally, the fourth option. F of x is differentiable, but its first derivative is not differentiable, means derivative of this first derivative. Okay, d by dx of d by dx, which means second derivative is not existing. So which means this is not existing, but there is no problem with these things. So you see, this is the correct answer. F of x is differentiable, but its first derivative is not differentiable at x is equal to 0. And what is the derivative of first derivative? They are asking about the second derivative. Okay, first derivative is not again differentiable, means second derivative is not existing. That's what they are mentioning in this question. Clear to all of you? Did you all understand this question? Did you all understand this question? Why option D is the most suitable answer for this question? I want answer from all of you because this is a quite good question. Yes? Okay. And what's the time by now? IST? Let us check once. It's 11:57. Oh my god. Okay, it's 11:57 anyhow. Okay, so I hope this is the last question that we are dealing today anyhow. So this is the topic that we are going to cover tomorrow in tomorrow's class. Basically the mean value theorems and Taylor series of single variable calculus. So these two topics are really important for GATE because in mean value theorems you'll find quite number of good questions that are coming. So I thought of giving this topic which I'm going to deal tomorrow, so that you have the link of the complete mathematics course which I gave you in the description box of this video. So you can click that full course link and you can find the video which is related to these topics, mean value theorems and Taylor series, and you could have some basic knowledge before attending tomorrow's session. Okay, clear? Am I clear so far? So tomorrow we are going to deal the concept of mean value theorems, problems related to the topics on mean value theorems and Taylor series, and this I have already covered in the full course that I offered in this channel, on this channel. So I have the link of that particular course in the description box of this video. So you can, whoever is new to this channel, please like the videos and subscribe so that you will be getting notifications of all the future courses that we are offering on this channel. Okay, and This link for this course is already in the description box. You can have a look at it before coming for the tomorrow's session. Clear? And for notes and all, you can scan these Telegram groups which are here. And of course, whoever is new to this institute, courses, you can always visit the website of this institute to get the better knowledge on what we are doing and what we are doing in near future and all. And for notes of every classes, you can scan the 2 groups behind me. We have one group for mechanical students exclusively and one group for others, ECE, TIBLE and all other branches. We have made it into 2 parts just to avoid the rush. Whatever we will be posting in this group, the same things we will be posting in this group as well. So there is no issue. But in future, for your core subjects related materials, we have done it into 2. Okay. And these are the contacts that if you are interested at any time, you can walk into our office. Our people are ready to guide you. Okay. And you are getting the links for mechanical Telegram channel and ECE Telegram channel. Other branches Telegram channel. Meanwhile, in the chat box. So you please join and subscribe these channels to get the notes of this. Okay. Because I know we are going very fast. It might not be possible for you to take the notes completely. So we'll be providing these notes on these channels. Okay. And please, once again, like and subscribe the channel. Like the videos and all. Thank you. Have a nice time.